Hello everybody. Welcome to this course, Fundamentals of Onboard Diagnostics and Vehicle Diagnostics. This is a course first of its kind which provides an extensive knowledge on onboard diagnostics and vehicle diagnostics. Without further ado, let's deep dive into the first chapter, which is Introduction to Onboard Diagnostics. Well, let's have a brief or rather detailed introduction about onboard diagnostics in automobiles. Now, what is this onboard diagnostics? So let's have an overview. Onboard diagnostics is vehicle's self-diagnostic and reporting system that monitors the performance of various subsystems, primarily the engine, the transmission, emissions, emissions control system, and it helps identify malfunctions, stores error codes, and provides detailed real-time data to assist the vehicle maintenance and repairs. Okay, in case you don't understand the meaning of error codes, don't worry, we will be explaining the meaning of error codes, the types of error codes, the nomenclature in detailed manner in different chapters. So as of now you understand from the name diagnostic itself. So this is a system which self-diagnoses the entire vehicle and monitors the various performance of the various subsystems. Now I'm sure all of you know that in a vehicle there are plenty of subsystems right from engine, transmission, chassis, body control, emissions, ADAS. So all these subsystems are proactively being monitored and diagnosed by this system called onboard diagnostics. Now, what are the various key components of onboard diagnostics or OBD-II? Now, why it is called OBD-II? Again, I will explain you very clearly. The first key component is OBD-II port or data link connector. This is something most of you would have seen. This is located right under the dashboard, usually near the steering wheel. The next important component is 16 pin connector, and next important component is the scanner tool, which is used to connect the scan tools to OBD readers. Now this is just a brief introduction. Okay, I'll be explaining about these tools, uh, all these tools very elaborately in the coming chapters. Next important key component of OBD is diagnostic trouble code, which is acronymed as DTC. And these DTCs are usually 5-character alphanumeric codes indicating specific issues. Now coming to the format, the first character, it represents the system. Second digit, whether it represents the SAE standard or manufacturer specific. Third digit, it represents the subsystem, and last 2 digits represent the specific fault. Again, I'm just touching upon these things for sake of introduction. I'll clearly explain you in a very elaborate manner when we come to the specific chapter. Now, what are the various OBD-II protocols? Different communication standards used by manufacturers. Now, SAE J1850 pulse width modulation is used by Ford. SAE J1850 VPW variable pulse width used by GM. ISO 91412 Chrysler, European Asian vehicles used by Chrysler and European vehicles. ISO 142304, this is also called a keyword protocol. And last but not the least, ISO 15765-4. And this is used by many modern vehicles, and actually it is mandatory since 2008. Next important component is monitored systems. All right, so this OBD-II continuously checks what are the various systems which the OBD is monitoring. One is engine control module, transmission control module, oxygen sensors, catalytic converters, exhaust gas recirculation, evaporative emission system, misfire detection, fuel system, airbag system, and ABS and stability control. All these systems are proactively or constantly under the vigilance of OBD. Now, how does this OBD work? Well, by now you would have gathered that the purpose of the OBD is to continuous monitoring, and it monitors the sensors, track the parameters like fuel mixture, exhaust gases, and engine performance. All right. Next comes the fault detection, and if a parameter deviates from the expected value, the system logs a DTC. Now, as on now, don't worry about all these things. When you don't understand, if you don't understand system logging a DTC, don't worry about it. We will be discussing elaborately when we come to the respective chapter. Next comes the malfunction indicator lamp, also known as check engine light. It alerts the driver of an issue. And next comes the data access. Mechanics or users can read DTCs and live data via an OBD2 scanner. Now, what are the benefits of OBD? The most important benefit is early fault detection. As I said, we are proactively monitoring and we can identify the problem before they cause major damage. Now, this is like this. Suppose somebody is having some tumor of some symptom of tumor. If you regularly diagnose your body, then symptoms of tumor can be recognized and prevented even before the tumor spreads to the entire body or it spreads in some sensitive part. So likewise, early fault detection, it identifies the problems before they cause the major problem. Okay, it immediately pinpoints, okay, here in this particular component there is a damage or there is a hazard of damage. Next important benefit is emission compliance. It ensures vehicle meet environment regulations, simplified repairs, provides precise error codes for faster diagnostics, and also real-time data logging. It helps in performance tuning and fuel efficiency analysis. Now, remote diagnostics, some modern diagnostics allow wireless monitoring. All right. Now, coming to the what are the various common OBD tools? The most important or rather most prevalent common OBD tool is basic code reader. It displays the diagnostic trouble code and clears them. Now, what is this clearing? At what interval it gets cleared? All these things we will be discussing in the respective chapters. Now, next comes the advanced scan tools, provides live data, graphing, advanced diagnostics, and there are even some advanced tools which use Bluetooth and Wi-Fi OBD adapters, which can be paired with the smartphones. And the name of those OBD tools is or Torque Pro or OBD Fusion. These are tools which are available in the market. Actually, they are available in Amazon. If you just go to Amazon or eBay, you will see these tools being sold. Next comes the dealer professional tools. OEM level diagnostics is Snap-on, Bosch. Now these are all the tools which are usually used at the dealer, at the service station by the authorized service technician. Now coming to the future of OBD, well, you would have guessed that the biggest future is wireless connectivity, remote emissions and diagnostics reporting. Next, predictive maintenance, AI-driven failure prediction, enhanced cyber security, protection against hacking in connected vehicles. Okay, first of course is wireless connectivity. Next is predictive maintenance. Already OBD means predictive maintenance, but the predictive maintenance as on now is driven by some software, but in future it will be driven by AI. And last but not the least, enhanced cyber security, because OBD scanner or the OBD 16 pin is the entry point from where hacking possibility is there. So enhanced cyber security is the need of the hour. So many people speculate that in future enhanced cyber security will be prevalent in the automobile. Now coming to the conclusion, OBD has revolutionized vehicle diagnostics, making it easier to detect and fix issues while ensuring compliance with emission standard from basic to advanced OBD and upcoming OBD-III. So as of now, which is being used is OBD-II and OBD-III is just around the corner. The system continues to evolve, integrating more sophisticated monitoring and connectivity features. All right, so this is the basic introduction. Now what all we have covered here, we are going to discuss in a very elaborate manner in the respective chapters. Thank you.